The only language that's been more unjustifiably maligned than JavaScript over the years has been various flavors of BASIC. Even though JavaScript became the de facto language of the web years ago, a lot of people shunned it because it's interpreted, loosely typed. For a long time it lacked good tool support, and it doesn't have many of the hip features that modern programming languages have. All that has changed in the last few years as JavaScript has taken on a crucial role in standards-based websites and applications. It's the driving force behind AJAX, which has enabled the creation of rich, highly responsive, and attractive websites that increasingly rival desktop applications in their functionality. All modern browsers support JavaScript, so it's the one broadly available non-proprietary automation technology that you can virtually always count on. Problems in the past where a user might have turned it off are less of an issue today, since it's increasingly rare that you have a site that doesn't use some JavaScript. Users who have it turned off are missing out on much of what the web has to offer. Now, one of the biggest problems that developers have faced when using JavaScript in web applications has been the inconsistency of support in various browser versions for language and the document object model. If you're creating a site for users who use only a specific version of a single vendor's browser, then this isn't too much of a problem. You just write the code for that particular browser. But if you're writing a public website, in the past you've needed to write some very ugly code to handle all of the idiosyncrasies of each browser and each version of each browser. But the good news is that browser incompatibilities are largely a non-issue now if you use a good JavaScript framework that hides these kinds of incompatibilities. And some of the frameworks include Microsoft's AJAX client library or jQuery, and there are a lot of other good ones. JavaScript is not an object-oriented language like C# and Visual Basic, but it is based on objects. In fact, one of the fundamental truths that you'll need to understand about JavaScript is that everything, and I mean absolutely everything, in JavaScript is an object. But they're not objects. They're not the kind of objects that you're used to in the .NET framework. .NET objects are instantiated from classes, which form a kind of template for an object that you instantiate in memory. And the classes define properties and methods. For the most part, you can't change a .NET object at runtime by adding or removing properties or methods. In contrast, JavaScript objects are more like a .NET dictionary object that consists of name-value pairs of values. There are no classes, so there is no template for creating instances of an object from a class, although there are some features that you can use to kind of fake that. You can create a new object and add properties simply by assigning a new value to a property on the object. For example, take a look at this code. What this is doing is it's creating a new point object with x, y, and z properties that hold its coordinates. And it also then creates a string in a location variable that uses the coordinate values. So notice that this code is creating the object on the fly, and it creates those x, y, and z coordinates simply by assigning values to them. You can associate any arbitrary value with any arbitrary property of a JavaScript object. And JavaScript objects can also have methods, which are defined as functions, which are created in a way that makes them look kind of like a kind of property. And here's an example of that point object again, with the x, y, and z, using a different notation for creating the object, as well as defining an add method, which is defined as a function that takes another point object and then adds the coordinates together. This is a very common way that you can use to create objects within JavaScript. It's a very dynamic process. Now, DHTML is an acronym for Dynamic HTML. This is a web standard. It's defined by the World Wide Web Consortium that lets you access and manipulate the elements on a web page. DHTML is dynamic because it uses JavaScript to modify elements on the page, both when a page loads and in response to user actions. DHTML isn't really a technology as such, but it's rather a faster way of saying HTML modified by JavaScript. JavaScript and DHTML team up to provide a rich set of tools for making your web pages really come alive and responsive to the user. One of the most common JavaScript functions that you'll use with dynamic HTML is the getElementById function. It's got to be the single most popular JavaScript function. The reason is because it enables you to easily find an element on the page by using its ID, the ID attribute that you define on an element. So here's an example of using the getElementById method in order to get a reference to the myDiv tag, which happens to be a div element. Most client-side JavaScript and AJAX frameworks provide a better syntax that really simplify accessing page elements and are much more flexible. But you need to know and understand the basic use of getElementById so that you can use those frameworks efficiently. A common way to create and append strings in JavaScript is to use an array object. Arrays are generally similar to arrays that you encounter within the .NET framework. Arrays in JavaScript are zero-based. They're not fixed in length, and they can continue to grow simply by appending to the end of the object. Arrays also have a length property that returns an integer representation of the number of elements that the array contains. Arrays in JavaScript use square brackets and an index to read or write values to a certain position in the array, which is called the indexer. So this is a common way that you'll use in order to add a new element to the array. The nice thing about using it this way is that this will add the added text, the new string, to the array at the end of the array object, no matter how large the array currently is. If this is the first element, then display.length is going to report 0. So the 0 element, which is the first element in the array, has a value of added text. If the array already has, say, 10 elements, then the length property will report 10. The actual element positions in the array are 0 through 9, meaning that it's zero-based, so assigning the 10 position adds a new element to the end of the array. So the beauty of using this display.length property in the indexer of the array is that it always returns the next position available in the array for a new element. There's various features that you can use with arrays. For example, if you want to pull together all of the content contained within the array into one long string, then you can use the array.join method. And that's how that works. The join method takes a separation string as a single parameter, and it'll use that separation string as an element delineator between each of the elements in the array, as it's joined back together in a single string. You'll very commonly use JavaScript in order to update the page. That's kind of the whole point of AJAX. And all HTML elements have an inner HTML property. This is the property that you use to change the contents of the element in question. If you assign a string to this property, it's going to replace all of the current HTML that is contained within that element. Here's an example of how you can write to the inner HTML property of the div tag. So you first get a reference to the div tag, and then you simply create a string of usually HTML and assign it to the property. Very easy to do. All HTML elements have a style property. This is the container for all of the CSS styles that are applied to a document. You can use any of hundreds of different subproperties which represent all of the style elements. It's actually pretty amazing the flexibility you have in all of the options in order to change the formatting and appearance of HTML elements. And you generally do this through cascading style sheets, and often using the style property. So some of the most common style properties would be background color, so you can change the color of the background behind text, the height of an element, or the width of an element. And that's just an extremely small sampling. So here's an example. Once again, have a div tag called myDivTag. Get a reference to it and put that reference in the div tag. And then you can set the inner HTML property to some HTML. And then you can access the cascading style sheets of that div tag through the div tag variable and its style property. And this is going to set the color of the text. Now, one of the difficulties in working with JavaScript is that each browser can interpret and name functions differently. While it's possible to accomplish just about any look and feel for a task in a single browser, the complexity of the task is going to increase greatly when you try to maintain the same look and feel in multiple browsers. It's just a lot of work. To complicate things, it's not just browser brands like Internet Explorer, Firefox, Opera, Safari, and so forth that vary. Sometimes one version of a specific browser acts differently than it did previously in the same browser. And Microsoft is probably the worst at this. With each new version of Internet Explorer, it enhances the support of Internet Explorer for open web standards. But this often means that the behavior changes substantially from version to version. Now, there's major benefits to using a good JavaScript framework. One of the reasons to use a good framework is that all of the commonly used functions are usually available for you to use as a single call. There's a single operator or a single symbol, whatever, in order to give you an entree into all of the features of the framework. And then the library ensures that the functionality is the same in all supported browsers, which means that it implements code internally to look at the type of browser, or what the W3C calls a user agent, and then adjust behavior based on which browser is accessing the page. So this is a huge benefit. When the framework you use is updated to support newer browsers and versions of browsers, your code will generally continue to work because the framework will make the right calls in each browser instance. It's absolutely amazing how far we've come in the last decade in order to make it easier to write cross-browser JavaScript. So now let's talk a little bit about data formats. JSON, or the JavaScript object notation, is a plain text data format that AJAX page developers commonly use. Plain text data formats are important for web developers because they're easy to transport over the HTTP protocol. They don't have to be converted into a different format or serialized. Well, sometimes you have to serialize, but you don't have to convert them into a different format just to send them over HTTP. And they're also easy to compress and serialize and deserialize when you need to do those things. Serialization and deserialization is the technique of persisting an object to a format that you can later use to reverse engineer in code. In other words, to rehydrate the object to make it usable within the code, say within a browser. To transfer an object in a web server, .NET often uses an XML serializer by default. This means that the object persists to XML when it's serialized, such as when you're using a web service. Then, in the deserialization process, the client code parses the XML and creates your object. So the most common data formats that you're going to encounter will be XML and JSON. And increasingly these days, you're going to be using JSON. Now, JSON uses a very simple format. It's a name-value collection. If you create a person object, for example, you can add name-value pairs to the person object that might look, act, and feel like properties in other languages. Now, there are various rules for creating JSON markup. First, you have to include all JSON markup within a single parenthetical notation, a set of parentheses. You need to enclose the name-value pairs within that set of parentheses within curly brackets. And then you separate the name-value pair values by using a single colon, such as this example. And then you need to separate arrays of name-value pairs, so you can start to get the sense that you can do some fairly complex things here. But you need to separate arrays of name-value pairs that are siblings by using a comma. And here's an example of that. The value of a name-value pair is often another name-value pair. So you can nest these things. Value of a name-value pair could also be a function. All right, there's more rules. The value of a name-value pair may be an array of name values, in which case you enclose the array of name values within square brackets. So you can start to get the sense that this is not a real human-friendly notation as you get more complex object notation. The value of a name-value pair may be an array of name values. And in that case, you enclose that array of name values within square brackets. And here's an example of that. So as you can start to imagine, as you get more complex JSON, it becomes less and less readable by humans. But one of the benefits is that it's very usable by machines, by your code. All right, now that example contains an array of URL objects, each of which have a name and URL value. If the JSON was in a variable named response, then you could use this code in order to deserialize it to a JavaScript object. So that's using the built-in JavaScript eval method. So that's the reason why JSON has become so popular as a data format for JavaScript in client browsers and using AJAX, because it is so easy to deserialize the data. Now you can iterate through the URLs within the array using this code. Notice that the code uses the array object to access each member of the array with a syntax that's common to most programming languages, using that type of for loop. All right, so far, the examples I've shown you, I've formatted the JSON in order to make them reasonably easy to read. Now, although JSON can be relatively easy to read, most of the examples that you're going to encounter in real-life development will not be in this kind of easy-to-read format. So when JSON displays in a less friendly format, it might just look like a collection of data with square brackets, curly brackets, and colons, which are its delimiting characters. And there's even still a relatively simple example. It's just not going to be all that easy for we as humans to parse this data. But again, it's a very easy format to parse using JavaScript. Now, the reason that JSON is the best serialization format for Microsoft AJAX development is because JavaScript and the browsers understand the format and can convert JSON to an object with the eval function. The eval function, as you saw, is a standard JavaScript deserializer that takes a JSON string and returns an object that represents the data passed in. Now, JSON is preferable to XML because the JSON data format is much more lightweight. XML has very verbose open and closing descriptive tags. So this makes XML easier to read, but it also creates a much larger payload during data transfers, when data is being exchanged between the client browser and the server. For small objects, the difference isn't really all that significant, but for larger objects, such as a fully populated data set that you've read from a database on the server, an XML representation of the data can be 10 to 20 times larger than the JSON representation of the same object. That excess bloat can dramatically slow down the performance of your web pages, which easily can make them unusable. The smaller footprint, coupled with a built-in deserializer in the web browsers, is the reason why it's become a very popular choice for web developers. All right, let's talk a little bit more about JavaScript objects. I've been talking about JSON and its string of navigation URLs, and then using the eval function to deserialize it into a URL's object array. You can also write that code using JavaScript objects. For example, here's some code that creates an object signature. It's very similar to creating a class in server-side code, complete with constructor parameters. And now you can create a nav object by passing in the name and URL of the navigation elements. So as you can see, this news up a nav object, and you can pass in the settings for the name and URL property in the proper order, much as you can with the .NET Framework constructor. So this code creates a new array and populates the array with two new nav objects, one for Microsoft.com and one for AppDev.com. So after you create and populate the object array, you can use code in order to cycle through the array, create an ordered list, and write it back to a results div tag, like this code does. So you can start to see how easy and dynamic it is to create objects, and then use those objects in various ways in order to update the contents of a page. Now there's lots of different ways of creating objects within JavaScript. So JavaScript lets you create objects that can hold data as well as functional methods, which are generally known as just functions. I've been talking about code that built the nav object, which held a name and URL. It created an array of the nav objects, cycled through the array, and then created a long string of HTML that you can put out in an ordered list of hyperlinks to the page. If that nav object is going to be converted into hyperlinks in multiple places, it makes sense to add a method that outputs the HTML markup directly, rather than duplicating the code that takes the object and generates the HTML. You want to avoid duplication in your code as much as possible. So you can add methods in the object declaration, much in the same way that you can add text properties. Keep in mind that JavaScript objects consist of name-value pairs. So when you create a function, the value of the name-value pair is the actual function. It's the body of the code. Thinking in name-value pairs will make it easier for you to write the code. So here's some code that defines a nav object that has two data fields and a single toLink function. The first two name-value pairs are pretty easy to visualize. This is a fairly standard notation. Name, URL, or properties, and you assign some value to them. The third name-value pair, which is called toLink in this example, and the value that's assigned to it is the actual function. And the function is that bit of JavaScript that returns the full HTML anchor tag with the href attribute set and the inner HTML set to the name property. This code creates a toLink method right within the object declaration. And this technique is known as an enclosure. It's pretty straightforward and easy to use. You define the method inside it. It's enclosed in the method declaration. Location alone doesn't qualify the method as an enclosure, but when you reference a this value inside the toLink function, it becomes an enclosure. Now that you have a toLink method, the code that you use to write out an ordered list of navigation hyperlinks is much smaller and cleaner. You don't have to include all of that code that creates the HTML each time you use this object. So it's important to remember that enclosures are defined inside of the method definition, which means that it requires more memory because an enclosure is allocated along with each object instance. If you have a single instance of an object, not a big deal. If you have a lot of objects, it can be a very big deal indeed. Now, what if you want to create a toLink method on the nav object, but the nav object was created in another place, maybe even by another system? You don't have access to the object declaration, so you can't enclose the toLink method within the object declaration. So JavaScript supports another option for adding a method to an object. It's called the prototype method. And this lets you add prototypes, add functions, outside of the object definition. What this code does is it creates a nav object with simple storage for a name and URL. So it doesn't create any toLink method within the object declaration. Instead, what it does is it adds the toLink function by using the prototype property that is available on all JavaScript objects. The benefit here is that it uses less memory because a prototype is only allocated once, and then it's reused for all object instances, all of those nav object instances. So it can be much more efficient. You might be thinking that since you're in charge of all your JavaScript object declarations, you don't need to use prototypes. But you need to consider another important element when deciding whether to use enclosures or prototypes. It's client memory. When code instantiates an object, the object and all its properties and methods allocate space and memory to hold that object. It's really important for you to remember that all JavaScript objects are essentially name-value pairs. The memory that JavaScript allocates for objects is merely an in-memory hash table. If your object is going to be reused many times, maybe in an array, then you should consider using prototypes instead of enclosures. And the reason is simple. You have to create enclosures for each object, whereas with prototypes, only one instance of the method loads into memory, and you can use the prototyped instance over and over again. For example, if you create 1,000 new objects with the toLink method built as an enclosure, you'll have 1,000 nav objects in memory, each with its own memory allocation for a toLink instance. And that's 999 more than you really need. Conversely, if you create 1,000 nav objects with a prototyped toLink function, then you have 1,000 nav objects in memory, but all of those objects point to the same single instance of the prototyped toLink function. Functionally, the toLink enclosure and prototype methods execute the same. The difference is the amount of memory that the objects consume, which can affect the speed of your runtime code. All right, that's a lot of the details that you'll need to know as you program JavaScript. It's just a very small part of what you need to know, so it's definitely worthwhile taking some time to learn JavaScript well. Even if you're going to use a framework in order to simplify your JavaScript, you need to be able to understand what the framework is doing. The ASP.NET team worked long and hard to make web development as easy and rich as desktop development, which has to overcome many of the hurdles of the web, such as the stateless HTTP protocol, the relatively constrained development environment in the browser, and the various cross-browser issues, and lack of basic application infrastructure. Consistent with that, Microsoft's implementation of AJAX is actually two entirely separate pieces wrapped in one neat bundle. The two pieces are server-side and client-side AJAX. And both of these handle entirely different scenarios and are based on radically different views of how to make pages more responsive to the user. You can certainly use both pieces within a single page, but most often a single page is going to rely on one or the other. Server-side AJAX fits nicely into the overall ASP.NET page processing model, since it relies on ASP.NET server controls. To develop a page that uses this type of AJAX, you drag and drop controls onto a web form, set some properties, and voila, you have an AJAX-enabled web page. ASP.NET 4.0 ships with 5 AJAX controls that you'll find in the AJAX extensions section of the Visual Studio Toolbox. The most important of these controls are the Script Manager and Update Panel controls. Script Manager doesn't have a user interface at runtime, but it's required, well, all the time you use server-side AJAX, and often by client-side AJAX. And it lets you configure the scripts that are necessary to implement AJAX, and it automates a lot of the process. The postback events of any controls you place in the Update Panel container will cause an AJAX request instead of a full-page postback, and it depends on how you configure the Update Panel and coordinate that with the Script Manager. It's really important to understand that most all of the AJAX processing occurs on the server, and the controls take care of updating just the section of the page within the Update Panel. From a developer's viewpoint, this style of AJAX feels much like development using full-page postbacks. All the features of these controls aren't fully implemented within the Visual Studio Designers, So you'll probably find that you're going to spend a lot of time in the source view of the page designer writing HTML, even if you typically use the design view. But the HTML that you need to work with is fairly straightforward, and the environment has full support for IntelliSense, so it really isn't an undue burden. The other piece of ASP.NET AJAX is closer to the original concept of AJAX, making requests for updated data and updating a page directly from the browser without hooking into the page events that dynamically create both full and partial page postbacks. The concept of a page or a page fragment is completely anathema to client-side AJAX, unlike its server-side counterpart. Microsoft's AJAX client library uses the extensibility features of JavaScript in order to make the language look much more like C# and Visual Basic, with features from the .NET framework. Microsoft also enhanced Visual Studio development tools to make writing client-side JavaScript much more productive than in the past. And there's no better example than the enhanced support for debugging JavaScript. The AJAX client libraries are implemented in JavaScript files, such as Microsoft-ajax.js and Microsoft.debug.js. Visual Studio installs two versions of most of these library files, both a debug and a release version. Make sure that you use the release version when you deploy a website. That's a version of the file that doesn't have the debug in it, because this version omits the debugging code and comments, and it's been minified, so it's a much smaller download to the browser. Also, Microsoft is gradually migrating to jQuery to replace its AJAX client library. The client library is still available. It's what was included with the initial release of Visual Studio 2010 and the .NET Framework 4.0. But you can use either of these frameworks, and it's going to greatly simplify the amount of code that you need to write.